important properties of logs. So these can be kind of confusing. So I really need you guys to make sure you guys are paying attention and studying these rules, because if you guys understand these rules, then the problems will be really easy. If you guys don't practice this, then the problems are going to be hard. So in this section, you guys will learn how to rewrite logs using different bases. You guys will learn how to use property of logs to rewrite or evaluate log expressions. You guys will learn how to, and this is a big part of your checkpoint when you guys take your checkpoint, expand or condense log expressions. And then we'll use some log functions to model and solve real life problems. That's a lie. That's not going to be in this section. I didn't include that. It'll be in the next section.
Teachers are releasing kids to the restroom.
Okay. So change of base formula. So you guys have learned how to evaluate some logs, right? Like log base 2 of something equals something. What if you don't know what the answer is? There's a way that we can change the base, and so we can do it easier on our calculator. So let A, B, and X be positive real numbers such that A is not equal to 1 and B is not equal to 1. So then log base A of X can be converted to a different base using any of the following formulas. Okay, so there's 3 equations that are all very similar. So what all these 3 mean is, let's say this is the problem I give you. So log base A of something. So remember, A is your base. And of course, my pencil's lagging. So let's say I want to convert it to log base B. B is just a number. The formula is going to be log base B of X divided by log base B of A. If I want to convert it to base 10, remember, if it's a log with base 10, do I have to write the 10? No. So what you would type into your calculator is, if this was the problem I gave you, you would just do log of X divided by the log of A. If it's a log with base E you want to convert it to, what type of logs have a base E that you guys learned about yesterday? ln, natural logs. So you would just do the ln of X divided by the ln of A. My heart's racing right now because I know the alarm's going to go off, so I'm trying to say this fast. What I want you guys... Dang it. Bear with me. All right. So a couple things I want you guys to notice. This is the base, and this is the argument, right? What I want you guys to notice is in our formula, can you guys think about this like the base is lower than the argument? Do you guys see how in the formulas, the argument is on top? Sorry, my laser's lagging. Can you guys see that this is like higher, this is lower? Do you guys see how the argument is on top and the base is on the bottom? It's the same for all 3 formulas. So if this is like the top, it goes on top. The base is below, it goes below. Okay, so that's how you can remember how the formula works. This is on top, goes on top, below, below. We have a log button on our calculator. We have an ln button on our calculator. We will very rarely use this one, okay? This works, but it's easier to use these 2. So these are probably the 2 that you guys are gonna use the most, okay? So what this does is, if we have something that we can't figure out, So for example, if I ask you guys like log base 3 of 9, remember, this means 3 to what power equals 9? So what would the answer to this be? 2. Okay, but what if I ask you guys to find like log base 3 of 11? Exactly. This is where this comes into play. If I plug this into one of these formulas, I could find the decimal approximation that would make this true. Okay, so that's why we need these formulas. All right, so let's do a couple problems. So use a change of base formula to evaluate each expression using common logs. Round to the nearest three places. So my question to you guys, common logs. What base do we use if we use common logs? 10. So in the box above, you guys agree that's going to be the second formula? Okay. So common logs, that means that we want a base 10 conversion. So that looks terrible. I'm going to rewrite that. Conversion. Okay. So before we do this, we got to set up our formula. So I want you guys to think about this is going to be like our A. And this is going to be our X. Okay, so what am I going to write on top? Well, what, just 25? Log of 25? Divided by log of 4. Remember your calculator has that fraction shortcut alpha x. So I would just type it into your calculator just like that. Since we're rounding, we want to use the approximation symbol. And you guys should get 2.322. Okay. Now you guys are my honor students, so I want you guys to understand why this makes sense. Okay? There's two ways you can think about it. I'm going to say this over and over and over again so you guys get annoyed with me. That's my goal. I want to be annoying because that means you guys know it. The answer to any log question is the exponent that makes this true. So in your calculator, if you check this, what's your base in this problem? 4. So you should check that 4, this is the exponent, right? That makes it true. 4 raised to the 2.322 power, is that close to 25? It is? What did you guys get? 25.002? That's pretty close to 25, right? It's not going to be exact, but as long as it's close, okay? Another way you guys can think about it is this is an exponent, right? You guys with me? This is an exponent. So if our base is 4, what I want you guys to think about it is, what's 4 to the first? Isn't that just 4? What's 4 squared? 16. What's 4 cubed? 64. Okay, now, do you guys agree that 25 is between these two numbers? So that means that the exponent that makes this true should be between 2 and 3. Is our answer between 2 and 3? It is. So that should make sense too. If we got like 5 point something, that's way too big. So we did something wrong. Okay? All right, cool. B. So I want to make sure you guys understand this. Before we actually plug it in, think about it. What's 2 to the first? 2. What's 2 squared? What's 2 cubed? What's 2 to the fourth? 16. So do you guys agree that 12 is between these two numbers, right? So does that make sense that our answer we're looking for should be between these two numbers? Okay, so let's see if it's right. So if I want to use common log, same thing. This is going to be the log of 12 divided by the log of 2. Yes, you should get 3.585. And oh my goodness, does it match our prediction? It does. Hey. Look how smart we are. Okay. Questions on this problem? Okay. We also have a different formula, so I want us to practice using that formula. Is everybody okay with part B? Can I move on? Okay. Example 2. I'm okay, guys, if you guys just write this, because the directions, I'm being lazy right now. The directions are the exact same, except we're just going to use natural logs. So if I want to use natural log formula instead, what's the only thing that's going to change? Instead of using log, we're going to use ln. So what number goes on top, 25 or 4? 25. So this is going to equal the ln of 25 divided by the ln of 4. And what we get? 2.322. Now, before we move forward, you guys are smart cookies. You guys are sharp. You guys pay attention. No one said anything yet. Did you guys notice something? It's the same answer. Isn't this also the same problem? I didn't make a mistake. I'm trying to show you guys something. Was this the same formula we used in the first example? It's not the same formula, right? It's a different formula. But what do you guys notice about the problem and the answer? It's the same. So what I'm trying to show you guys is, does it matter which formula you use? No, because 4 to some power should be 25. That answer should be the same. So what I'm trying to show you guys is you have, unless it tells you guys what to do, you can use whatever formula you want. It doesn't matter, okay? So in that case, let's just prove that this works. Let's do the other one again. But now let's use LNs. Let's double check. So use your calculator. Let's check that the ln of 12 divided by the ln of 2, does that give us the same answer? It does. So it's 3.585. Okay. Any questions? Okay. I'm gonna give you guys a few minutes. Can you guys try this with your table? Okay, math is a language. Logs are its own language, which you guys will learn right now. So in order to solve some problems, here are some important properties of logs. Let a be a positive real number such that a is not 1, and let n be a real number. If u and v are also positive real numbers, then the following properties are true. So I need you guys to write a little bit small just so everything fits nicely. Okay. What does product mean? To a multiplication problem. Product means multiply. So log base A of u times v is equal to multiplication means addition in log language. So this means this is the same thing as log base A of u plus log base A of v. So product multiplication means add. You have to know this. Now, why does this work? What is the inverse of logs that we've talked about? Exponential. So if I give you guys something like this, x squared times x to the 4th, that would be x to the 6th. And that's because multiplication means do what? Add. That's where that comes from. That's why that's true, okay? All right, if it's an ln, it's the same thing. The ln of u times v is the same thing as the ln of u plus the ln of v. All right, so now that you guys know that, let's see if this makes sense to you guys. Quotient means division, okay? So the log base A of u divided by v, what's your prediction that we do? Subtraction, good. Subtraction order matters. So this means log base A of u minus log base A of v. Division means subtraction in log language. We can do the same thing with ln's. The ln of u divided by v is the same thing as the ln of u minus the ln of v. Okay. Power, this one's weird. This one's a little bit different than what you'd expect. If I give you guys log base A of some number u to the nth power, this is going to be a common theme for the rest of the chapter. This is a base, right? This is the argument. Whenever you guys write your final answer, we don't want the power on top of the argument. So there's a shortcut to what we could do, and that's we're going to bring this power to the front. So this is the same thing as n times log base A of u. So same thing, if it's the ln of u to the nth power, that's the same thing as n times the ln of u. We can take this power and bring it to the front. I could prove it to you guys, but I feel like you guys are just gonna look at me like I'm crazy. And I don't wanna confuse you guys. You guys believe me? It works? All right, cool. Easy. Okay, I'm gonna warn you guys, the next problem is gonna seem very weird at first, but once you guys get good at these are actually kind of fun. They're like little puzzles, okay? I'm excited to see you guys' reactions. Okay, is everyone good here? Okay. So this is a long problem. We're gonna have 6 parts. So we're going to use log base B of 2 is approximately 0.3562. Log base B of 3 is approximately 0.5646. And log base B of 5 is approximately 0.8271 to find the following. Okay, on purpose, I didn't put the base because I don't want you guys just to plug it into your calculator. I want you guys to use the log properties. So this is what I want you guys to do. So for part A, we're gonna find log base B of 15. Okay. So what I want you guys to focus on is for this problem or any of these problems that you guys will see like this, you guys will be given some arguments. These are the numbers that we're going to use to help us solve these problems, okay? So we're trying to evaluate log base something of 15. We don't know what that something is. However, we're given some decimals to help us out. So how does this help us? My question to you guys is there anything you guys can think of that I could do to get 15 by using any of these numbers? What? Yes, you guys agree that 5 times 3 gives me 15, okay? So this is how I want you guys to show your work for this. This is the same thing as log base B. We know that 15 is the same thing as 3 times 5. Okay? What'd you guys just learn to do if it's multiplication with logs? Add. So this is the same thing as log base B of 3 plus log base B of 5. Okay? This, they told us what this decimal is. So this is the same thing as 0.5646 plus 0.8271. And if we add those together, we get 1.39 0.17.
So, are you guys 3 and 5?
What's 3 times 5?
So that's going to be like 7.5.
Do we have 7.5 here? You can only use the numbers I gave you. We don't even know what the base is, so we can't use 7.5. Does that make sense? Okay. That's why it's like a puzzle. You're like, how could I get there? And then just think about it. All right, B. This is a cool one. So if you have an idea of what to do, raise your hand. Don't be shy. Well, what would be so one thing I want to tell you guys is sometimes there's more than one way to get there. Which number is going to help us out the most to get to 27? 3. How could I get 27 using 3s? 3 times what? Yeah, isn't 3 to the power of 3? Isn't that 27? Okay. So what I want to show you guys is there's actually more than one way to do this one. So this would be the first method. You don't have to do both methods on like a test or your homework, but I just want to show you guys there's different ways you can do this one. Log base B of 27. 27 is the same thing as 3 cubed. What was the rule if there's a power on top of the argument? Where do I bring the power? Bring it to the front. So this exponent is going to come down to the front. Okay, so this equals 3 times log base B of 3, which is equal to 3 times 0.5646, which is equal to 1.6938. Are we comfortable with that? Okay. You guys probably won't like this one, but this technically works too. What's another way to write 3 cubed? 3 times 3 times 3, right? So another way you guys could do this is log base B of 27 is the same thing as log base B of 3 times 3 times 3. So you could break it apart. What does multiplication mean to do with logs? Adding. So this would be the same thing as log base B of 3 plus log base B of 3 plus log base B of 3. Which, if you guys notice, how many log base B of 3s do I have? 3. So if I add them all together, it'd be the same thing as taking it and multiplying it by 3. So 0.5646 plus 0.5646 plus 0.5646, and that is still 1.6938. So it doesn't matter which one you guys use, whatever one you guys like better. All right. So those are like easy ones. Let's make it harder. C. So not a trick question. Can anybody think of a way I can get that number by using the numbers I gave you guys? Yes, because it's a decimal, that tells you should do what? You have to divide something. So play around with the numbers, guys. What's a way that we can get 0.4? Perfect. 2 divided by 5. Good job. So this is the same thing as log base B of 2 divided by 5. What's the rule for division? Subtraction. Subtraction order matters. So log base B of 2 minus log base B of 5. So that's going to equal 0.3562 minus 0.8271. And we get negative 0.4709. Which hopefully makes sense, right? Because our answer is negative. Remember I told you guys what type of exponents give us a fraction? Negative exponents. So that should make sense. Okay? All right, let's make it harder. Ignore that. D. Okay. Let's say you guys had no idea what to do. What I would do is I would do a factor tree. And Luis, if you're right, you'll get the same numbers. Okay? So give me 2 numbers that would multiply to give me 90. 3 times 30. 30 is the same thing as? Oh yeah, it works. 6 times 5. And then 6 is the same thing as 2 times 3. Okay, what I want you guys to notice is you guys notice the numbers at the end of our little branches? Those are all the log numbers I gave you guys. So 3 times 3 times 2 times 5. So this is the same thing as log base B of 3 times 3 times 2 times 5. So I could actually be smart about this is because what's another way to write 3 times 3? 3 squared. So this is the same thing as 3 squared. Because don't I have a rule for that guy? Sorry, my laser's not working. I have a rule for that one, right? So what's multiplication mean with logs? Add. So this is going to be the same thing as log base B of 3 squared plus log base B of 2 plus log base B of 5. Okay, power rule. I can bring the exponent here to the front. So this is going to be 2 times 0.5646 plus 0.3562 plus 0.8271. These? Those are the ones that I gave you. You just don't overthink it. Just use the decimals that I gave you. And then whatever your answer is, you can just leave it the way it is. Because if this is 4 decimal places, whenever you guys do the problems, they're also going to be 4 decimal places. Okay, so what did you guys get? 2 point. What? 3125? Cool. Questions? Sorry, I'm like super deaf. What's it? Yes. Yes. That replaces the 9. Okay. Here's one that is interesting. Division means subtract. So this is going to equal log base b of 1 minus log base b of 3. Now question, is this one of the ones I gave you guys? But what is this? 0. Good, because b is just a base, right? What exponent always gives us an answer of 1? 0. So this is a tricky one because you guys might be like, what the heck? I don't know what that is. It's always 0 if it's 1. Okay, so this is going to be 0 minus the 0.5646, which is negative 0.5646. Okay, last one, and I'm done torturing you guys. I want to make sure you guys understand this. Talk to your table. Ask each other. Make sure you guys know what this means. Victor, did you guys talk to each other? Alex, are your table good? Paula, is your table good? Your table good? Guys, what does that bar over the 3 mean? It repeats, right? Does it ever stop? So doesn't this mean 3, 3, 3, 3, 3, 3, 3, 3, 3 forever? Okay. I want to make sure because the last time I taught this lesson to my regular pre-calc class, I had a good number of kids that they told me they'd never seen that before, and that made me a little scared. So I don't know if they're just pulling my leg or they just really never learned that. But this means it keeps going forever. Okay. So what type of operation should we try to do then to get a decimal? Quotient, right? Division. So I need to rewrite this as log base b of something. Okay, so let's just see if you guys have an idea. Look at the numbers I gave you guys, 2, 5, and 3. Are you guys aware, like, what number can I divide by to always end up with a 0.33333 at the end? Yeah, if you divide something by 3, do you guys agree that will end up with a 0.33333 at the end? So the question becomes, what number must go on top? 3 divided by 3, give me 1. 10. Good. This is the same thing as 10 divided by 3. Now, class, do we have 10 as one of our numbers? But what do we have? 5 times 2. Oh my goodness, we're so smart. Log base b of 5 times 2 divided by 3. Now, this one's important because both of these are on top. What does multiplication mean? Add. So I'm going to add these two together first, and then division means subtract, and then subtract the bottom. So we're going to break this up as log base b of 5 plus log base b of 2, and then minus log base b of 3. So 0.8271 plus 0.3562 minus 0.5646, and that's going to give us 0.6187. Okay, I'm going